Good morning, all of you. Are you able to hear me?
Yes, ma'am. Ma'am, I had a certain doubts regarding GOC. Can I ask them at the end of the lecture?
Yeah, you can ask me at the end. From which book you have?
Ma'am, the notes and
Okay,
the
no.
the module.
Okay. What about MS Chauhan? Have you started doing that MS Chauhan for GOC?
No, ma'am.
And when are you all planning to start?
Ma'am, actually, I'm covering up the backlog right now because the classes are going to start offline. So,
Yeah. In fact, I wanted to speak to you all about this because 1st March, you know that we are starting off with the offline
yes, ma'am.
classes, correct?
Yes, ma'am.
All of you have this. Okay. So before that, like whatever backlogs you'll have for every subject, please try covering it out. Because I think April ending, we would cover the 11th standard syllabus and 12th standard would start somewhere around May. So please don't carry your 11th standard backlog to your 12th standard because 12th standard is going to be a very short, what you say, from May to, I think you'll
December.
get only December, yes, to study. Fine. That's hardly, I think, 6 to 7 months where you have to complete double the portion what we have done now. So what we are going to do in 11th standard, the syllabus for 12th, which we are going to have is almost double than what we are going to do it in the 11th, than what we have done it in the 11th standard. So,
Ma'am, I had a doubt. When are the dates for our uh,
bolo.
s- when are the dates for our batch? Like the J dates. When are the J dates going to be held? When are they going to inform us?
This year's JE still has not, the dates have not yet come out. No?
So the next year is okay.
So for you, it will be definitely, you all will come to know the dates around, say, October or November when the forms are out.
Okay, ma'am.
But this year's JE still, the JE mains is not even, they don't even have the any idea like when the exam is going to be held because
But it's
forms are,
February already.
yeah, that's what. So I think now the JE mains will be after boards only because during board exams they cannot have the JE mains. So maybe JE mains will be somewhere around April
Okay, ma'am.
and then June maybe or May end or June they'll have their JE advanced. Okay. And I think they should have just 2 attempts for JE mains this year, if I'm not. Because 4 attempts it won't be
Next year also it will be two, right?
Even advanced has 2 attempts.
Advance has only one.
I told you I'll discuss the booklet. Tautomerism, did I start?
Ma'am, we finished Tautomerism yesterday.
Acid catalyzed, base catalyzed also I did.
No.
No,
We
ma'am.
did ketones and the other one I forgot.
Keto enol tautomerism.
Yes, keto enol tautomerism.
Okay, and did I do the diad, triad, tetrad, pentad systems?
Yes, ma'am.
Okay. So I think the left out was ring chain tautomerism. I told you I'll be doing. What else I told you I'll be doing in tautomerism? Is my voice not clear?
Yes, ma'am. It wasn't clear. It's clear now.
And now?
Yes, it's clear now.
Okay. Ring chain tautomerism और कौन सा कहा था मैंने? What else was remaining? I told you listing. Tautomerism and other functional groups, no? And then I have to do acid catalyzed and base catalyzed. Okay. Fine. Ring chain, let me give you an example for that. Now say if I have a compound something like this. This is the aldehyde carbon. This is the alpha carbon. You know what is an alpha carbon, correct? I've told you what is an alpha carbon.
Yes, ma'am.
So alpha carbon now has OH group. Now can I say this is more acidic than this one? Why would this be more acidic? Because the H is bonded to what?
Oxygen.
So that makes this hydrogen acidic. So what can happen is this can come out as H plus. And as it comes out as H plus, O will get a negative charge. That negatively charged oxygen. I'll just show it like this. H comes out as H plus, O gets a negative charge. That negatively charged oxygen can attack this carbon. The pi bond on this carbon can shift to oxygen. What charge will develop on this oxygen now?
Negative charge.
So this H plus will then migrate there. So I'll get CH2, C, O gets a negative charge where this H plus migrates. And this O now is bonded here. Can I say I get the formation of a ring here? And there is a migration of a proton. Formation of a ring and migration of a proton. Migration of a proton is known as tautomerism. And since you're getting a ring being formed here, this could be quoted as an example for ring chain isomerism. In this case, you get a 3-membered ring. This would give you a how many membered ring?
4.
This would give you a 4-membered ring. This can form a 5-membered ring. So these are examples of ring chain isomerism. Sorry, tautomerism, not isomerism. Ring chain tautomerism. Tautomerism क्यों बोला है? Because it is a migration of a proton. Okay, did you all finish writing this? Okay, just write it down. Okay, all of you have completed, I think. Fine. Now there are other functional groups which also can show tautomerism. So tautomerism is not restricted to keto and enol. So other examples of tautomerism. Okay. I could give you an example of a compound having nitro functional group. Now again, this is the alpha carbon. The hydrogen on this alpha carbon is found to be acidic. H can come out easily as H plus. And why it can come out easily as H plus? Because if H plus comes out, the carbon ion formed here will be resonance stabilized. So this H is going to come out as H plus. The electron pair would shift in here to form a double bond. This electron pair shifts in here to oxygen. What charge would come on oxygen here? Can I say negative? So H plus will migrate to that negatively charged oxygen. So what I'll get is CH2 double bond N OH O. This is a nitro form and this is the isonitro form. Again, what will happen? How will this convert back into this? This electron pair would shift in here to form a double bond. This goes back here and H migrates here to give you this form. So again, this is an example of prototropy. Then it can also happen in a nitroso compound. This is nitroso. Nitro is NO2. Nitroso is NO. Again, what can happen? This hydrogen is acidic. It can come out as H plus. This electron pair will shift here. This migrates here and this moves here. This is the nitroso form and this is the oxymino form. How will this convert into this? The electron pair shifts here, this moves here, and this migrates here. यहाँ पे क्या होगा? This group is known as the amide group. CONH is the amide. This will shift here. This migrates here, and this will shift here. This is the amide. This is known as imidic acid. एक मिनट मैंने गड़बड़ कर दिया. रुको. इसमें एसिडिक हाइड्रोजन कौन सा है?
नाइट्रोजन पे लगा है
हाँ,
वो.
ये वाला. That will migrate, not the other one. Okay? So it is this hydrogen which will migrate. ये इधर शिफ्ट होगा, H प्लस निकलेगा, ये यहाँ शिफ्ट होगा और ये जो H है वहां माइग्रेट करेगा. This is that imidic acid. Now this amide is open chain amide. If you use a cyclic amide, now this is a cyclic amide. Cyclic amides are known as lactam. Lactam represents a cyclic amide. इसका tautomer क्या होगा? Which H will migrate?
Which is on the nitrogen.
Yes, so that will migrate. How is tautomerism different from resonance?
In resonance, there's electron pairs or electrons, but atoms are not moving. Here, atoms actually move.
Yes, so here it is a migration of proton. Electrons तो होते हैं साथ में H plus भी migrate होते हैं. This is lactam, this is lactam. Lactams are cyclic amides. Could you tell me the tautomer for this? Anyone, can you try and tell me? इसका acidic hydrogen कौन सा है?
The one on the nitrogen.
Yes.
NH2.
लैक्टिम के बाजू का स्पेलिंग लैक्टिम है, लैक्टिम. हाँ, so the H will come out from here. Wait, I'll show you. H plus will come out. Electron pair will shift here. This goes on nitrogen. What charge will develop on nitrogen? Negative. So can I say H plus can migrate here? इसमें कौन सा फंक्शनल ग्रुप है ये? This is an amine functional group. CnH2 is amine. Okay, let me just tell you. C with NH2 group. What is this functional group called as? Amine. What is C triple bond N known as? C triple bond N is known as what? This is cyanide or nitride. But what is a C double bond N known as? C double bond N is known as imine. तो ये होता है सिंगल बॉन्ड होता है तो अमाइन होता है कार्बन और नाइट्रोजन के बीच में. If there is a double bond, it is known as imine, and if there is a triple bond, this is cyanide. Here there is a single bond, so it's amine. Here there is a double bond, so it becomes imine. You have amine, imine, cyanide. So these are all examples of tautomers. Did you all finish with these?
मैम राइट हैंड साइड सेकेंड लास्ट कॉलम में वो क्या लिखा है ब्रैकेट में? एन्यूल
ये
अमाइन
वाला
नहीं, इसके नीचे जो अमाइन है उसके नीचे CNH2 के ब्रैकेट में, इसके ऊपर। हाँ
ये अमाइन है ना. C single bond NH2 is amine. C double bond NH is amine. Yeah, this part is amine ना, देखो.
यस मैम।
This is C single bond N ना. ये amine है और ये C double bond N. So it's amine. ये 7C triple bond N is cyanide. अच्छा, I saw it now. Okay. Okay, now write down acid catalyzed tautomerism. Sorry, I'll change the color of the marker. Now, tautomerism can be catalyzed by an acid or a base. Acid catalyzed tautomerism. I'll take up first. You add a dilute solution of an acid to the aldehyde or ketone. Enolization होता है और जल्दी होता है. You know what is catalyzed reaction? No? What do you mean by a catalyzed reaction? The reaction will occur at a faster rate. So first I'll take up the mechanism of acid catalyzed. Okay, now pay attention. How does this acid catalyzed tautomerism takes place? In acid catalyzed tautomerism, you add an H plus ion. H plus will be attracted where? Could you tell me H plus कहाँ पर attract होगा? Yes, it will be attracted towards the oxygen. Oxygen has a delta minus charge here. So H plus will be attracted to oxygen. It will go and attack the lone pair on oxygen. So oxygen will share its lone pair with H. Because of that, what charge will develop on oxygen? Could you tell me the charge developed on oxygen? Formal charge क्या आएगा oxygen? Oxygen should have 6 valence electrons. 1, 2, 3, 4, 5, 6. Here it is having how many? 1, 2, 3, 4, 5. So 5 valence electrons. So it will have a positive charge. Fine. Now because of this positive charge, what it will try to do? It will try to withdraw this electron pair from carbon. And as it tries to withdraw the electron pair from carbon, the carbon becomes electron deficient because the electron pair is being taken over by oxygen. So what this carbon does? It tries to pull this electron pair towards it. So now this electron pair, as this electron pair shifts here, simultaneously ये bond इधर electron pair यहाँ shift होता है to form a double bond, and this H comes out as H plus. So this H plus moves out. You'll get a double bond formation between carbon and carbon, and this is how you get the enol form. This H plus is from the acid which you added, and this H plus which comes out is from the molecule itself, that is acetone. So this acid H plus is from the acid which you have added, but this H plus which comes out now is from the molecule of ketone. This will again then undergo tautomerism. ये इधर shift होगा, ये इधर shift होगा और ये H migrate to give you back the keto form. Again this ketone will react with H plus in the same way. So it will proceed like this. Again you'll get ketone. Again that ketone will react with H plus. So this will keep on happening. Mechanism all of you have understood or no? Acid catalyzed. Okay. So if you have understood the mechanism, then you need to answer my question here. Just answer these questions. Look at the mechanism and then answer. Okay, Pranav, I'm explaining once more. H plus will be attracted to the lone pair on oxygen. So first step will be the protonation of this oxygen. Protonation means attack of proton on the oxygen. Oxygen will share its lone pair with the H plus, because of which it will develop a positive charge. So this oxygen becomes electron deficient. It will pull the pi bond towards itself. The pi bond shifts, मतलब electron pair shift हो जाएगा, तो oxygen को अपना lone pair मिल जाएगा वापस. जैसे ही electron pair shift होगा, carbon develops a positive charge. So what this carbon will do? It will pull the electrons from this bond, the bond present between alpha carbon and hydrogen. So that electron pair is pulled away by carbon. So this electron pair shifts in here to form a double bond. And this H comes out from the molecule as H plus. That H plus is taken into the solution. So this is how you get the enol form. Enol form, how will that happen? The electron pair would shift in here to form a double bond. This simultaneously shifts here. Carbon develops a negative charge. So the H plus migrates there. And that is how you get back the keto. So keto to enol to keto. This keeps on happening in the solution. What is D plus? D is an isotope of hydrogen. So instead of adding H plus here, I'm adding D plus. So I want you to tell me the final enol and the final ketone which I'm going to get. Did you all finish? Is water playing any role in the mechanism? Is there any role of water in this mechanism? Or is only H plus reacting? What is the role of water in this reaction? Is water reacting with the ketone? Yes, water is just the medium, but does it react with the ketone? Or is only H plus reacting? अरे your mechanism समझ में आ रहा है या नहीं आ रहा है? At least to answer that question. Water doesn't react, but H plus is reacting. So I want you to give me the product here. Instead of H plus, I have taken D plus. So what should I write here? You tell me. This is going to give me this ketone after tautomerism. All the hydrogen atoms are going to be replaced by deuterium. Did anybody of you get this? Did any one of you get this? See, till you don't answer me, I will not be able to teach.
Ma'am, can you explain the last part again?
For the mechanism?
Yes, ma'am.
Okay. This H plus has come from where? This is the H plus which you are adding in the solution, correct? That H plus gets attracted to oxygen. Protonation of this oxygen takes place. Because of that, oxygen develops a positive charge. Now, since it is positively charged, what the oxygen will try to do, it will try to withdraw the pi electrons towards itself. As the pi electrons shift on to oxygen, carbon becomes electron deficient. So what this carbon will do? It will pull the electrons from the adjacent CH bond. That electron pair shifts in here to form a double bond. And this H from the molecule of acetone, it is removed from acetone. It goes into solution as H plus. So this goes into solution as H plus. And you get the enol. Enol will not stay like as it is, no? Enol has to change into keto form also, no? So the keto form mein kya hoga? This electron pair will shift back here. From the enol, this electron pair will shift back here to form a double bond. This electron pair simultaneously shifts here. A negative charge will be created on carbon. So H plus will migrate there. And that is how you get the keto form. But this H has come from where? You all have to tell me now. This H is coming from where? That H on oxygen has come from where? Yes, from the acid which you have added as the catalyst. So can I say this H is from that acid? And finally this H is going to go on to this carbon. So instead of H, if I take D plus here, that D plus will be going to oxygen first. And from this oxygen, that D plus will go to carbon to give you that keto form. In that ketone form, the D will be on carbon. See, I'll show it to you now. I'll show you the entire mechanism. But this time I'll do it with D plus now. So instead of H plus, now I have added deuterium here. So first step will be same. Attack of deuterium on the oxygen. Because of that, oxygen will develop a positive charge. Now what this oxygen will do? It will try to withdraw the electron pair. So this electron pair will shift on to oxygen. Carbon becomes electron deficient. So this carbon will pull this electron pair towards it. So this H will go out as H plus. This goes into solution and you will get CH2, double bond C, OD, CH3. Till here, all of you have understood or no? Adisha, I'll show you the last slide. But first tell me whether all of you have understood this part till here or no. Okay. Now this is the enol form. Enol का tautomerism होगा. Tautomerism में क्या होगा? ये electron pair यहाँ shift होगा. ये electron pair यहाँ shift होगा. Carbon will develop a negative charge and the D plus will migrate to carbon. So you will get CH2D, C double bond O, CH3. This part is understood again? प्रणव थर्ड स्टेप कहाँ है बच्चा इसमें? थर्ड स्टेप तो यही है, टॉटोमेरिज्म है लास्ट में। कौन सा थर्ड स्टेप बोल रहे हो आप? ये वाला। ओके, डी प्लस ने पहले अटैक किया यहाँ पर, ऑक्सीजन डेवलप्स अ पॉजिटिव चार्ज, तो ये इलेक्ट्रॉन पेयर को विड्रॉ करेगा अपनी तरफ। जब ये इलेक्ट्रॉन पेयर विड्रॉ करेगा तो उसका लोन पेयर वापस आ जाएगा, इधर एक और लोन पेयर आ जाएगा। बट जब ये इलेक्ट्रॉन पेयर विड्रॉ करेगा तो कार्बन पॉजिटिवली चार्ज हो जाएगा, तो ये कार्बन क्या करेगा, ये बाजू वाले कार्बन हाइड्रोजन बॉन्ड का जो इलेक्ट्रॉन पेयर है उसको पुल करेगा अपनी तरफ, तो ये इलेक्ट्रॉन पेयर पुल होकर यहाँ पर डबल बॉन्ड बनेगा एंड दिस विल कम आउट एज H+। तो ये H+ जो बाहर आया है वो कीटोन का H+ है, और यहाँ पर जो D+ ने अटैक किया है, ये D+ आपने ऐड किया है एज अ कैटलिस्ट। अब ये जो इनॉल बना है, ये इनॉल का जब फिर से टॉटोमेरिज्म होगा तो ये जो D आया था ऑक्सीजन पे वो अभी शिफ्ट हो जाएगा कार्बन पे। Till here, have you all understood everything? Okay, Disha, this is the last slide. Just copy it fast.
मैम जो मैकेनिज्म के नीचे जो लाइन है उसमें सारे रिवर्सिबल एरोज नहीं आएंगे?
I can't hear you. Is someone saying anything?
मैम वो बोल रही है कि वो मैकेनिज्म है ना,
कौन सा?
ये H+ ऐड किया वहां पे और रिमूव भी किया, तो वहां पे डबल एरो नहीं आएगा क्या?
अच्छा, हाँ हाँ।
डन मैम।
This one all of you have understood now. Now this ketone which is formed again, that ketone will again react with D+ which you have added. Again that D+ will go to oxygen. Pay attention now on what I'm doing. So oxygen पे D+ attack करेगा. Give me the charge on oxygen. Yes, oxygen develops a positive charge. So now what this oxygen will do? It will withdraw the electron pair. And when it withdraws the electron pair, carbon becomes electron deficient. So now, now this adjacent carbon has 2 hydrogen and 1 deuterium. So one of the bond has to break. Either the CH bond or a CD bond has to break. And the electron pair has to shift here to form a double bond. Now the question is which bond will break here? The CH bond or the CD bond? A CD bond is 7 times stronger than a CH bond. A CD bond is found to be 7 times stronger than a CH bond. So now you tell me which bond will break.
CH.
Yes, the CH bond will break. The electron pair will shift here to form a double bond here. So as this electron pair shifts to oxygen, this electron pair will shift here to form a double bond. And this H will go into solution as H+. And what I'll get is CH, D, double bond, C, OD, CH3. Till here, all of you have understood. Okay. Now this is again the enol form. Enol will undergo tautomerism. Tautomerism में क्या होगा? ये electron pair यहाँ shift होगा. This will shift here. Carbon develops a negative charge. This D+ will then migrate here. So I'll get CH, D, D, C double bond O, CH3. So can I say already I have got 2 deuterium on the alpha carbon? Again, now what will happen? With D plus, तो D plus यहाँ पर आएगा, इनॉल बनेगा उसका, इनॉल का जो D है यहाँ पर वो कीटो फॉर्म में जब जाएगा तो वो D माइग्रेट होगा अल्फा कार्बन पे, और अल्फा कार्बन से H जो निकलेगा वो बाहर जाएगा सॉल्यूशन में। जब यहाँ पर तीनों जगह D आ जाएंगे उसके बाद ये वाला H माइग्रेट करेगा, मतलब ये वाला H निकलेगा, धीरे धीरे ये तीनों H भी रिप्लेस हो जाएंगे D से। So after a number of steps, all the alpha hydrogen here will get replaced by deuterium. Is this understood now? This will repeat, at least total repetition will be 6 times. 6 times repeat होने के बाद क्या होगा, ये सारे जो अल्फा हाइड्रोजन है वो रिप्लेस हो जाएंगे ड्यूटेरियम से। 6 बार क्यों बोला मैंने रिपीटेशन? बिकॉज देयर आर 6 अल्फा हाइड्रोजन। तो हर एक बार एक एक H रिप्लेस हो जाएगा D से, और CD बॉन्ड स्ट्रांग हो गया। अब ये CD बॉन्ड स्ट्रांग हो गया तो इसके आगे फिर रिएक्शन नहीं होगा, कुछ भी रिएक्शन यहाँ पे रुक जाएगा, बिकॉज CD बॉन्ड रिक्वायर्स वेरी हाई एनर्जीज टू ब्रेक। Anyone who's not followed can ask me. और ये लिख लेना वहां पे, CD bond is 7 times stronger than CH bond. Anyone not understood the mechanism, you can ask me the step जो नहीं समझा है।
मैम ऐसे ये क्वेश्चन था, अगर ड्यूटेरियम की जगह ट्रिटियम डाला
तो फिर ये अल्फा कार्बन पे ट्रिटियम आ जाएगा, and a CT bond is 15 times stronger than a CH bond. So there you will get, instead of D here, you will get T here on carbon. Do you know that vibrational energies of a bond is directly proportional to its reduced mass? Have you heard about this?
No, ma'am.
Have you heard about moment of inertia?
Yes, ma'am.
Moment of inertia, how is it related to reduced mass? Reduced mass क्या होता है पहले? Reduced mass का formula होता है. What is the formula for finding out the reduced mass? That is M1 into M2 upon M1 plus M2. You know this? Where M1 and M2 are the masses of the two elements which are forming that bond. Say for example, if I take HCl, M1, M2 will be mass of hydrogen and mass of Cl. So M1 into M2 upon M1 plus M2. This is the reduced mass. And moment of inertia is inversely proportional to reduced mass. मास ज्यादा होगा अगर, तो उसका इनर्शिया कम होगा. Do you know this? You all might have done this in physics. Okay? अगर मास ज्यादा है तो उसका इनर्शिया कम होगा, और इनर्शिया कम होगा मीन्स द वाइब्रेशंस कम होंगे मॉलिक्यूल में, और वाइब्रेशंस कम होंगे मीन्स अगर वाइब्रेशंस कम हो रहे हैं तो बॉन्ड जल्दी ब्रेक नहीं होगा ना. मतलब उसको एनर्जी बहुत ज्यादा लगेगी बॉन्ड को ब्रेक करने की, क्योंकि जब तक वाइब्रेशन नहीं होगा बॉन्ड ब्रेक नहीं होगा. जब तक वाइब्रेशन नहीं होगा बॉन्ड ब्रेक नहीं होगा. So you have to have, if you want the bond to break easily, it should vibrate easily. और vibrate कब होगा? जब उसमें inertia कम होगा. inertia कब होगा? जब mass ज्यादा होगा. So if I take a CT bond, can I say CT bond will have more mass, reduced mass as compared to CD bond? Which again has more mass than a CH bond. तो इसका reduced mass maximum है, इसका reduced mass maximum है, तो मतलब इसका vibrational energy maximum होगा. That means the energy needed to vibrate a CT bond is very large as compared to the energy needed to vibrate a CD bond. So I can say that CT bond will require more energy to break. So it is stronger than a CD bond and a CH bond. ये वाइब्रेशनल एनर्जी का कंसेप्ट समझा है या नहीं समझा है? इन शॉर्ट, अगर मास ज्यादा है तो मतलब यू नीड मोर एनर्जी टू ब्रेक दैट बॉन्ड, एंड इफ यू नीड मोर एनर्जी टू ब्रेक दैट बॉन्ड, आई कैन से दैट बॉन्ड इज गोइंग टू बी स्ट्रॉन्गर बॉन्ड. सीटी बॉन्ड विल हैव मोर रिड्यूस्ड मास. प्रणव क्या नहीं समझा बच्चा? इतना क्लियरली तो मैंने लिखा है यहाँ पर, वाइब्रेशनल एनर्जी इज डायरेक्टली प्रोपोर्शनल टू द रिड्यूस्ड मास, और वाइब्रेशनल एनर्जी यू कैन रिलेट इट विद बॉन्ड एनर्जी. बॉन्ड एनर्जी इज डायरेक्टली प्रोपोर्शनल टू द रिड्यूस्ड मास. जिसका मास ज्यादा होगा वो एनर्जी ज्यादा यूज करेगा बॉन्ड ब्रेकिंग के लिए. ठीक है? तो सीटी बॉन्ड का मास ज्यादा होगा ना एज कंपेयर टू सीडी. टी का रिड्यूस्ड मास ज्यादा होगा या इसका ज्यादा होगा, डी का? ट्रीटियम is an isotope of hydrogen with mass number of 3. Deuterium is an isotope of hydrogen with mass number 2. And hydrogen is a isotope of hydrogen again. Protium. These are the three isotopes. इसके मास 1 है, इसका मास 2 है, इसका मास 3 है. इसका मास ज्यादा है मतलब रिड्यूस्ड मास भी ज्यादा होगा, और रिड्यूस्ड मास ज्यादा होगा तो वाइब्रेशन एनर्जी ज्यादा होगा, वाइब्रेशन एनर्जी ज्यादा होगा तो बॉन्ड एनर्जी ज्यादा होगा. So you'll need more energy to break a CT bond as compared to CD, which will require more energy to break as compared to a CH bond. ठीक है? Mechanism, I'm explaining it once more. I think there are some students who have still not understood the mechanism. Pay attention now again. You are adding D plus. D plus will get attracted to the lone pair on oxygen. So D plus the oxygen will share its lone pair with D. Because of that, it develops a positive charge. So what this oxygen will do, it will try to withdraw the pi electrons towards itself because it is positively charged. So as these pi electrons shift back to oxygen, oxygen will get back the lone pair. But जब ये pi electron shift होगा, carbon becomes electron deficient. So what this carbon will do, it will pull the electron pair of the adjacent CH bond towards itself. This electron pair shifts in here to form a double bond, and this H comes out from the molecule as H plus. This H plus goes into solution. ये H plus कहाँ से आया है? एसीटोन से आया है, तो ये H plus बाहर निकल गया और ये इनॉल फॉर्म बना. इनॉल ऐसे ही नहीं रहेगा, it has to change back into keto. तो जैसे ये कीटो फॉर्म में जाएगा क्या होगा? This electron pair will shift back to form a double bond here. Simultaneously, this electron pair will shift here to form a negative charge on carbon, and this D plus will come out and it will migrate to carbon. So the D from oxygen has gone to carbon. फिर से क्या होगा? Keto form मिला है. अब keto form will react with the D plus which you have added in the solution. That D plus will get attracted to the lone pair on oxygen. फिर से ये ऑक्सीजन इलेक्ट्रॉन पुल करेगा, ये इलेक्ट्रॉन पेयर पुल होगा कार्बन की तरफ, तो यहाँ डबल बॉन्ड बनेगा और ये इनॉल बनेगा. ये H प्लस जो है दैट विल गो इनटू सॉल्यूशन, पर ये H प्लस एसीटोन का है, ठीक है, ये सॉल्यूशन में चला गया. यहाँ पर डबल बॉन्ड बना तो ये इनॉल बना. अब इनॉल का जब टॉटोमेरिज्म होगा तब ये डी माइग्रेट करेगा इधर. अच्छा, यहाँ पे ये ऑलरेडी जब एक डी आ गया था तब दो ऑप्शन थे अब मॉलिक्यूल में, या तो ये बॉन्ड ब्रेक होके H प्लस निकलेगा बाहर, या तो ये बॉन्ड ब्रेक होके D प्लस निकलेगा बाहर. विच बॉन्ड विल ब्रेक इजिली, CH बॉन्ड और CD बॉन्ड? Which bond will break easily? Definitely CH bond. So this bond will break, the electron pair shifts in here to form a double bond, and the H leaves out from the molecule to give you this enol. अब ये enol में ये D plus इधर migrate करेगा to give you this. Again what will happen? This keto form will react with D plus. D plus यहाँ पर attack करेगा, फिर से ऑक्सीजन पे प्लस आएगा, पाई बॉन्ड शिफ्ट होगा और बाजू वाले कार्बन से H प्लस निकलेगा, क्योंकि D नहीं निकलेगा, यहाँ से H प्लस निकलेगा, because CH bond will be weaker than a CD bond, so H plus will come out. फिर इनॉल बनेगा, that इनॉल will again उसका D plus इधर माइग्रेट करेगा और वो कीटो फॉर्म में चेंज हो जाएगा. धीरे धीरे क्या होगा, सारे जो CH bonds है, अल्फा कार्बन जो है जिसपे हाइड्रोजन है, सारे अल्फा कार्बन हाइड्रोजन bonds will change into CD bonds. CH bonds will start changing into CD bonds. Is this mechanism understood now?
Yes.
Of course, पहली बार कर रहे हो mechanism, तो it is going to take little efforts and little time for you to understand. But I think once you start understanding एक दो तीन mechanisms ना, आगे के mechanisms बहुत easy हो जाएंगे आप लोगों के लिए. ये पहला mechanism है इसलिए आपको you're finding it difficult. Yes, Saab, this has to stop, na? Because now the CD bond, the energy needed to break the CD bond is almost 7 times more than the energy needed to break CH bond. Agar ye CH bond room temperature, you know, tautomerism is spontaneous, I have told you. That means the energy of the room temperature was sufficient to break the CH bond. But now the breaking of CD bond will require much higher energy, no? Which is not available at room temperature. So it will finally stop here. Okay.
और मैम अगर एनर्जी होगी CD बॉन्ड ब्रेक करने का, उसके बाद भी दूसरा डी ही आके अटैक करेगा.
हाँ, डी आएगा,
तो
फिर
फर्क ही
फाइनली
नहीं
वो ही डी
पड़ता.
आ जाएगा उसके बाजू वाले कार्बन पे, समझा? तो फाइनल प्रोडक्ट तो यही होने वाला है. Now my question to you is, here I have added H plus and D2O. So now tell me whether these alpha hydrogen will be replaced by D. यहाँ पर D plus H2O था, तो सारे alpha hydrogen replace हो गए D से. Here I am adding H plus and D2O. I am taking heavy water here. Is there any role played by water in this mechanism, or only D plus is involved? Is the water anywhere reacting with the ketone?
No.
I have shown you the mechanism here. No, there is no reaction of water. So only D plus attacks the oxygen. यहाँ पर D plus की जगह मैंने क्या ऐड किया है? H plus. तो H plus attack करेगा. So here the enol form will be this one. और इसका टॉटोमेरिज्म होके कौन सा कीटोन बनेगा? ये ही वाला बनेगा. Okay. So here there won't be any incorporation of deuterium in the molecule. What about the last mechanism? Last mechanism, I'm adding D plus here and D2O here. Will the deuterium get incorporated on the alpha carbon? will these alpha hydrogen be replaced by deuterium is my question. Yes, here also you'll get all these alpha hydrogen getting replaced by deuterium. And why is it so? Because the D plus will attack the oxygen and mechanism will go like this only. ये जो इधर पीछे वाला mechanism है. My God, what is the problem coming up? I'm not able to get it that why you are not understanding this. I've already explained it 3 times. Only D plus is involved here. Water is not at all involved in any of these steps. So water plays no role in this. Whether you take H2O, D2O, T2O will not matter. The only thing which will matter here is whether you have taken D plus, H plus or T plus. If you have taken D plus, the D will get incorporated on the alpha carbon. But if you have taken H plus, then it is H on the alpha carbon. That's all. Is the mechanism not explaining this part? Either you all answer me or I stop teaching. Saad, what is the problem coming up? You have to tell me. No, you cannot just remember the result, my dear. There are millions of organic reactions. How will you remember the result? You have to go through the mechanism. Will you remember the result of every maths problem given to you? Now you need to answer my question. Do you remember? Will you be able to remember the answer of every maths question you do it in class? Then how are you going to solve the maths questions? How are you going to going to get the answers? You need to tell me, Saad. How do you get the maths answers? If a question is given to you, how do you get the answer for that? By solving it? You go through some logical steps and get the answer? Yes? Organic is same like maths. You have to go through logical steps, which is known as mechanism. Only then you will arrive at the answer. अगर mechanism नहीं समझा है तो organic छोड़ना पड़ेगा पूरा का पूरा organic छोड़ना पड़ेगा आपको, क्योंकि mechanism बगैर आपको answers नहीं आएंगे. अगर maths में आपको logical steps नहीं आ रहे हैं, can I say you will not get the answer? Same way organic, if you're not knowing the mechanism, how to arrive at the answer, you can never go and get the answer. There is no difference between organic and maths. Maths also, you have to use your logic, use the steps, proper steps to get the answer. Same way organic also, you have to go through the proper steps, which are known as the mechanism, and arrive at the answer. There are millions से भी ज़्यादा reactions है organic में. Will you be able to remember the answers for everything? Okay. So these are the steps involved, and these steps is known as the mechanism. What part again I repeat, if you have not understood any part here, you tell me now what is not understood. Yes, if you're adding tritium, if you're adding T plus here, then what will happen? I'll show you the mechanism with T plus also. Fine. I'm adding T plus now. तो यहां पर क्या हो जाएगा? I'll get a tritium here. Oxygen will develop what charge? So now what will happen? Now this electron pair will shift to oxygen, simultaneously causing the movement of this electron pair here to form a double bond. H plus निकल जाएगा यहाँ से, ये H plus बाहर आ जाएगा. And what I'll get is CH2 double bond C OT CH3. Now this is the enol form. Enol will again tautomerize. Tautomerism में क्या होगा? ये इलेक्ट्रॉन पेयर यहाँ शिफ्ट होगा, ये इलेक्ट्रॉन पेयर यहाँ शिफ्ट होगा और ये T माइग्रेट करेगा वहां पर. So I'll get CH2T, C double bond O, CH3. So this is the keto form which you will get. Again, what will happen? Again, the T plus which you have added, that will go to this oxygen. यहाँ पे T plus will attack. Oxygen will develop a positive charge. It will pull the electron pair. Now carbon becomes electron deficient. So it is going to pull the electron pair from the adjacent carbon. Will the CH bond break this time or CT bond?
CH.
CH will break. So when CH will break, can I say I'll get CH, T, double bond C, OT, CH3. This part is understood? Again, जब इसका टॉटोमेरिज्म होगा, ये T इधर माइग्रेट करेगा. Did you understand this now? Saad, have you understood this? What about the others? Okay. So acid catalyzed tautomerism I've shown you. Now I'm going for base catalyzed. My God, अभी तुम लोग का एक ही नहीं हो रहा है, दूसरा अभी देखती हूँ. ये पूरा लिख लिया है. I know I've made so much jumbling up here. But were you able to copy it earlier? Okay, so now I'm going for the base catalyzed. Base catalyzed means now you're going to add a base. Something like OH minus in presence of water, of course. अच्छा, अभी इसका ये reversibility sign I have to show. OH minus. I'll show you the mechanism and then I'll show you the product. अब ध्यान दो. You have added a base. Base reacts with an acid. These alpha hydrogen atoms are acidic in nature because as H plus comes out, the negatively charged carbon will be resonance stabilized. So H plus will be removed by the base. H plus and OH minus will combine to form water. As this H plus goes with OH, carbon will develop a negative charge. So here you get the formation of a carbanion. Now this carbanion, इसमें resonance होगा. Resonance का you have to show this arrow. This is resonance. Give me the charge on oxygen. Give me the charge on oxygen. Yes, negative charge. So now this will react with water which you have added. Water will dissociate, giving you H plus and OH minus. What will go to that negatively charged oxygen? Negatively charged oxygen के पास क्या जाएगा? H plus या OH minus?
H plus.
हाँ. So H plus will go there. ये H कहाँ से आया है आप बताओ? This H is coming from where? Yes, very good. It is coming from water. Okay. Now this is the enol. Enol का फिर tautomerism होगा. और ये H migrate करेगा यहाँ पर. Giving you back the keto form. अब ये जो H इधर migrate हुआ है, वो H कहाँ से आया है? Water से आया है या कहाँ से आया है? The H which has been transferred to carbon. Yes, that is from water. Very good. So now, based on the mechanism, you need to answer my question. So complete these reactions. Did any one of you get? Waiting. Okay, I have some answers here. Uh, can I say the role of OH minus here is just to remove the hydrogen? But the water gives its D to the molecule and the D is incorporated on the alpha carbon. Yes. In this case, it is OD minus, which will just remove the alpha hydrogen. But here you have added water. तो water add किया है तो बस ये इनॉल बनेगा उसका, because ये H plus water से आएगा और फिर ये इनॉल टॉटोमराइज होकर ये ही कीटोन देगा. This part is understood. So here there is no incorporation of deuterium. Deuterium here will be incorporated only when you use heavy water, that is D2O. Yes, in the second and third, you will have the enol in which the D will be fate. D will be incorporated into the enol form. And this then will tautomerize. इसका जब tautomerism होगा तो ये D जाएगा alpha carbon पे. Did you understand this? ये last वाले में भी यही होगा. The D will be incorporated on the alpha carbon. Is this understood now? Because here again you are using D2O. So in basic medium, the D2O will play the dominant role. In acidic medium, water doesn't have any role. It is only the H plus which will matter. Is this understood, all of you? अभी doubt है कुछ भी? ये धीरे धीरे क्या होगा, सारे जो अल्फा हाइड्रोजन है will be replaced here by deuterium. प्रणव सेकंड कौन सा वाला बच्चा? सेकंड मतलब ये पूरा वाला, ये मैकेनिज्म. ओके, इसमें आपने बेस ऐड किया है. The OH minus removes the alpha hydrogen. बस उसका वो ही रोल है OH का, to remove the H plus. जैसे ही H plus निकलेगा, you will generate the carbanion. That carbanion resonance. Resonance में ये इलेक्ट्रॉन पेयर यहाँ शिफ्ट होकर डबल बॉन्ड बनेगा. Simultaneously this shifts here. Oxygen will develop a negative charge. Now the water gives its H plus to this. So जब water इसको H plus देगा, you will get this enol. जब टॉटोमेरिज्म होगा, ये H जो है वो माइग्रेट करेगा अल्फा कार्बन पे, और ये H कहां से आया? वाटर से आया. तो अगर आप वाटर H2O यूज कर रहे हो तो ये H कार्बन पे आ जाएगा, मगर वाटर की जगह अगर D2O यूज कर रहे हो तो यहाँ D आएगा और फाइनली वो D कार्बन पे चला जाएगा. So it will depend whether you have used H2O or D2O. Accordingly, you will get the product. Here OH or OD will not matter at all. Is this part clear now? किसी को कुछ भी डाउट है यहाँ पर? Okay. So if I take something like this, now I want the final answer. Okay, let me see. Okay, D plus D2O I have given. Arey? Okay. Give me the answer for this. कहाँ डी इनकॉर्पोरेट होगा अल्फा कार्बन? In which of these cases will D plus be incorporated on the alpha carbon? Just tell me, I'll tick mark those. I'm numbering these. Say this is first one, second one, third one, fourth one, and fifth one. So in which cases I'll get the product as this. I want this as the product. Okay, first one तो होगा, second होगा कि नहीं होगा? बेस कैटेलाइज्ड है और आपने D2O ऐड किया है. बेस कैटेलाइज्ड में this has to play a dominant role, correct? Yes, तो इसमें भी होगा. 3 में होगा कि नहीं? एसिडिक मीडियम है. एसिडिक मीडियम में किसका डोमिनेंट रोल होता है? हाँ, D प्लस विल प्ले अ डोमिनेंट रोल. सो इसमें भी होगा, इसमें भी D आएगा. ये बेसिक मीडियम है. बेसिक मीडियम में दिस प्लेज अ डोमिनेंट रोल. यहाँ पे H2O है, सो दिस विल नॉट इनकॉर्पोरेट ड्यूटेरियम. ये एसिडिक मीडियम है. एसिडिक मीडियम में ये प्लेज अ डोमिनेंट रोल, दिस डजंट. सो H प्लस तो H ही रहेगा यहाँ पर. सो योर आंसर विल बी 1 2 3. Anyone having a doubt? Okay. Have all of you understood this?
वाले में क्यों नहीं आएगा?
किसमें?
फिफ्थ वाले में.
फिफ्थ वाले में कौन सा मीडियम है?
एसिडिक.
Acidic medium में this doesn't play any role, no? Look into the
हाँ.
mechanism. This is the acidic medium. This is the H plus from where? This here. This is not going to play any role. So H plus का protonation होगा यहाँ पर और फिर यही H migrate करता है अल्फा कार्बन पे. Am I right?
Yes, ma'am.
Is water ever coming into picture here?
No.
So if water is not there, can I say this D2O will not have any role in the reaction? So this H will protonate here. You will get the enol, and that enol will tautomerize, and that H only will migrate to carbon. Did you understand now?
Yes, ma'am.
Okay. Fine. Any questions here? Any part which you have not understood? Second वाला बेसिक मीडियम है ना, और बेसिक मीडियम में इसका रोल आता है ना. देखो अभी तो किया था मैकेनिज्म. बेसिक मीडियम में ये OH माइनस H प्लस को निकालता है, फिर O पे नेगेटिव आता है, जो वाटर आके अपना H देता है ना. तो वाटर की जगह अगर मैंने D2O ऐड किया तो D आ जाएगा इधर, और वो D जाएगा फिर अल्फा कार्बन पे. सो अल्फा कार्बन विल हैव द D. So in basic medium, if you are using D2O, the D will be incorporated on the alpha carbon. Clear now? Okay. Okay, now how to remember के इनॉल कंटेंट, अगर आपको 5-6 मॉलिक्यूल्स दिए हुए हैं और आपको पूछा है इसमें से इनॉल कंटेंट किसका ज्यादा होगा, then how you will identify? That part I'm telling now. Just give the heading as increase content. increasing enol content. Okay, just write down now. सबसे कम होता है एल्डिहाइड का, जैसे ये कंपाउंड है. Next is beta keto ester. Beta keto ester, something like this. with yes हाइड्रोजन बॉन्डिंग अगर है तो H वाला जो D वाला जो है उसका बॉन्ड स्ट्रॉन्गर होगा हाइड्रोजन बॉन्डिंग. D will form a stronger hydrogen bond. इसको ये भी बोलते हैं एसिटाइल एसीटोन भी बोलते हैं इसका नाम. इसका कॉमन नेम एसिटाइल एसीटोन है. Then ये डायल होगा. एक मिनट, ये डायल मैंने रॉन्ग प्लेस किया है. डायल विल बी बिफोर द बीटा कीटो एल्डिहाइड. वेट आई एम सॉरी, डायल यहाँ पर है. Then you'll have beta keto aldehyde. Then you'll have your beta diketone. इसको एसिटाइल एसिड.
बीटा कीटो एस्टर के बाद क्या है?
बीटा कीटो एस्टर के बाद ये डायल है. ईडीजी क्या होता है?
इलेक्ट्रॉन डोनेटिंग ग्रुप.
हाँ, ये खाली बेंजीन है. EWG क्या होता है?
इलेक्ट्रॉन विथड्रॉइंग ग्रुप.
इलेक्ट्रॉन विथड्रॉइंग ग्रुप. I want to write few more. Just copy these first. Did you all finish writing? Acha, write down. Okay, I think you all have done. Are you done with this? Let me take the next. वैसे I think it will be easy for you to predict because पता है कि इलेक्ट्रॉन विड्रॉइंग ग्रुप है तो इनॉल कंटेंट बढ़ेगा, नो इलेक्ट्रॉन विड्रॉइंग ग्रुप तो उसका इनॉल कंटेंट कम होगा वैसे. So this will have the highest enol content. इसका इनॉल ऐसा होगा भी. This hydrogen is highly acidic. A complete conjugated system, इलेक्ट्रॉन विड्रॉइंग ग्रुप्स भी हैं और हाइड्रोजन बॉन्डिंग भी है इनॉल. So I think this order will help you predicting the enol content. Fine. Have I asked you all to do the exercise 1 for homework? उसमें से मैंने टॉटोमेरिज्म मना किया था करने के लिए शायद.
Yesterday you told you can do the home assignment one.
Okay,
and the
okay.
exercise
Did you
one.
try any questions from Tautomerism?
Not yet, ma'am.
Okay. And when are you planning to do so?
Ma'am, this weekend.
अभी आज कल तो लेक्चर नहीं होगा ना मेरा.
नहीं मैम, कल लेक्चर नहीं है.
अच्छा. ओके आयशा, आई थिंक फर्स्ट टाइम कर रहे हो ना टॉटोमेरिज्म के क्वेश्चंस, थोड़ा सा दिक्कत आने वाला है. आई नो दैट. आई विल बी सॉल्विंग इट इन क्लास, डोंट वरी. At least now again you try it once more. देखते हैं क्या होता है. Okay. Fine. No, Chambur I don't teach, bacha. And let me do ring chain isomerism. That is the last part of structural isomerism. Next class I'll complete the booklet exercise 1 and I'll start with stereo isomerism. This is not ring chain tautomerism, it is ring chain isomerism. This is the last type of structural isomerism. This is simple. In fact, I think I've told you. What is the molecular formula for this compound?
C4H8.
What is the molecular formula for this compound?
Let's hear few replies and responses.
Can I say both are C4H8? But then one has an open chain of carbon and the other has ring of carbon. So both these ring chain isomers. In fact, even this I can say. This has also the molecular formula C4H8. All these three are C4H8. This and this is ring chain isomerism. This and this is ring chain isomerism. What about this? These two both are rings, na? These are chain isomers. 2 and 3 are chain isomers. One and 3 ring chain. 1 and 2 also ring chain. They have the same degree of unsaturation. Okay, degree of unsaturation same होता है. जैसे इसमें 1 degree of unsaturation है, 1 pi bond है. इसमें भी 1 degree of unsaturation है, इसमें भी 1 degree of unsaturation. तभी molecular formula same आएगा ना, जब degree of unsaturation same होगा. So now I'm giving you a question. Write all the cyclic structures. I want only cyclic. I don't want open chain. Write all the cyclic structures with the molecular formula C5H8. So if a question of this type is given to you, how do you go about? The first thing is you'll calculate the degree of unsaturation. Give me the degree of unsaturation for this compound. 2. So 2 degrees of unsaturation. I don't want to write an open chain compound. I just want cyclic. So what combinations are possible? I can have a compound with 2 rings, or I can have a compound with 1 ring and 1 double bond. So write down all those compounds having the molecular formula C5H8, either having 2 rings or having 1 ring and 1 double bond. Chalo, do so fast. Last 5 minutes remaining. Or you can take this as a homework also. Fine. 5 मिनट में तो नहीं होगा. नहीं कर लो कर लो कर लो कर लो कर लो. Are you all getting it? How many all have got abhi tak?
I got 5, but I'm getting more.
Okay, so what? It's better you take it as a homework. Fine. You'll get many more. Don't worry. Write on 2 rings, 1 ring and 1 double bond. Then I'll give you the open chain ones also. Open chain में DU 2 है, मतलब कौन सा होगा? Can I say it can have 2 double bonds? Or it can have 1 triple bond. So write down all these. Write all the structures with the molecular formula C5H8. including the rings one also and the open chain ones also. So all these combinations are possible. Get it for me in the next class, along with exercise 1. Okay, I'll stop here now. Ojas, your offline classes will begin from you're in Andheri branch or which branch? Andheri starts at 7. 7 to 1:30 you'll have your lectures. 1:30 or maximum 2, I think. It'll be at least 4 days a week. Remaining 2 days you'll have your...
We have to reach there.
Yeah, 7 o'clock the classes start. Other branches start at 7:30. But Andheri we start at 7.
I think some time ago when the other started offline, we had it like 8 o'clock.
No, 8 o'clock to never, I don't think. I've been teaching in Dadar since so many years.
No, during COVID only. I think they had offline lectures only for physics. That was just 2 days.
Okay, that was during COVID maybe, but not now. Abhi to, I don't know actually what they're planning this time. Usually the lecture starts at 7. Before COVID, it was always Andheri branch used to start at 7 and the other branches at 7:30. Borivali also 7:30. Nerul also 7:30.
Mom, can I ask my doubts?
Yeah. How many questions you have?
They are general questions.
Okay, tell me. Yes,
Mom,
they're starting everywhere. Okay.
Mom, in the notes, you have for minus I effect, you have mentioned COH is has a higher minus I effect than fluorine, but in the module it is given opposite. Like fluorine has more minus I effect than COH. That's what's given in the
Can you send me
module.
the screenshot of that where the module says it?
Yes, ma'am. 1 second.
See these orders, you are going to find these problems. There are 10 different books giving you 10 different orders. So this problem is going to be there. Like OH and OR also, इसमें जब deactivating है, OH जब deactivation का मैंने table जो दिया था, decreasing activation, उसमें कितने books में OH is above OR, but then few books also have OR greater than OH.
Mom, but then answer will also differ, right?
That's what, no, this problem is going on since so many years. Nobody is making a proper.
I have sent the pic, yes.
Okay, COH they have given between fluorine, chlorine, bromine, fluorine and chlorine.
Yes, ma'am.
Okay, I'll just check about this. Fine.
Yes, thank you, ma'am. And ma'am, I have one more doubt. Where do we place NH3NO2 in the minus I effect list?
NH3
NO2.
No, but here there is a charge on ammonia. No?
Yeah, sorry.
It is not NH3NO2, it is NH3 plus greater than NO2. That greater than sign is missing over there.
Oh, okay.
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 Yeah. This COH I'll just check.
Ma'am,
Because I don't think this is the order.
Okay, ma'am. Ma'am, 1, 3, 5, 7 cyclooctatetraene.
Okay.
Ma'am, in the name, A and E are like together. Isn't that kind of wrong? Like
No.
shouldn't be
Tetra,
together,
no,
right?
no. This you don't have to bother. This you don't have to remove. Only when the first primary suffix ends with a vowel and the secondary primary suffix begins with a vowel, then you have to drop.
Can you repeat?
Say for example, if you have ene and ine together, this is a,
But ene and ine cannot be together, right? They are the second.
why can't you have a ene and ine?
Oh, okay, right, right.
So
Sorry.
when you have ene, this is the secondary suffix. Sorry, primary suffix, no?
Primary suffix, yes, ma'am.
This is primary suffix. This is also primary suffix. So when the first primary suffix ends in a vowel and the second primary suffix begins with a vowel. Now this spells like a vowel.
Vowel, yes.
So spelling is not a vowel, but then it
It
sounds
spells
like a
like,
vowel.
yeah. You'd
So then
mentioned it.
these two vowels are not to be placed together, then you have to draw. There are only certain places where you use these rules, not everywhere.
Okay, ma'am.
Fine.
Also, the last element which we have in the minus I effect, the list, is it safe to say that it has a lot of plus I effect, if not the highest?
Which element I have given you for the last one?
It has hydrogen. Hydrogen is last, but hydrogen
Actually,
is
for
last.
hydrogen, we take it as 0.
Okay, hydrogen
Inductive
is
effect is
null.
0
We can say null.
for hydrogen.
Okay.
So hydrogen is taken as a reference element. All those showing minus I are going to be withdrawing electrons from the carbon chain. And all those showing plus I, they are going to
Donating.
donate electrons to the
Yeah.
carbon chain. Fine.
Yes, ma'am. My question was something else though.
You're talking about what? I didn't get.
I was saying the elements on the minus I list. The last element will have a lot of plus I effect. Can we say that?
No, how?
Okay.
Because those have given you in minus I only, na? Those elements.
Yes.
Those
ma'am.
groups have given you only in minus I, no?
Yeah, true.
Okay. Say for example, yeah, Sushmita, are you there?
Yes, ma'am. There.
My this got disconnected. I've given you a list of compounds showing minus I with the maximum minus I shown by NR3 plus.
Yes, ma'am.
This goes on with hydrogen. I think I've given last as hydrogen. No?
Yes, ma'am.
So all those groups which are before hydrogen, they are going to be withdrawing electrons.
This is like that electronegative list, right? Hydrogen.
Yeah, correct.
Okay. Okay.
And all those showing plus I. Plus I में मैंने कौन से दिए हैं like O minus, CH2 minus and all that, no?
Yes, ma'am.
So all those are going to donate electrons. Hydrogen is at the center. This is the reference.
Okay.
So for
Okay,
this, there is
understood.
no inductive vehicle. But
Understood.
these will show plus I and these will show minus I.
Understood. Yes, ma'am. Thank you.
Yeah. Chalo, bye. I'm ending the class now. Fine.
Yes, ma'am. Thank you.